the first post-coffee break presentation.
I will. I just don't want to breathe everyone nervous.
Commercial farm production by Naomi Naude. Naomi works for Future Finboss. She did her bachelor's degree and master's degree at Stellenbosch University and started her graduate research. She did an internship at Future Finboss. They were so pleased with her that they offered her a position. So she is now a researcher with Future Finboss, and her area of research is she's involved in plant breeding and post-harvest research. So, thank you, Naomi.
I think they're still corralling in some attendees. Okay, I'm going to start then. Good morning, everyone. My name is Naomi Naude. I'm from South Africa and associated with Future Fynbos as well. So today I will be reporting on various facets and aspects surrounding our South African commercial Ayoba Arctic ice production. You just have to believe me that the flowers are all white. Fortunately, that's what we're dealing with. So if we look at the South African king Protea exports, we mainly export currently seedling Protea cynaroides, dominated by the pink variants over there. And if you look at our clonal production, we then export Madiba, Red Rex, and Clare in the red category of exported kings, King Grand, which is a pink variant, and then the pure white Ayoba Arctic ice, which is managed by Future Fynbos in South Africa. Looking at the export season for 2022 to 2024, South Africa exports the majority of our kings during the spring period. And you'll see that 21 to 24% of our exports occur in September and 33 to 44% in October. So this is clustered around one period, whereas you see very low frequency flowering during the rest of the calendar year, which we export. Then Fuchs found that the general flowering period of cynaroides variants are highly conserved in terms of when they flower, even when they are planted outside of where they occur in their natural habitat. So studying around 80 ecotypes of cynaroides, it was found that a lot of the wild populations actually do flower outside of the spring period. You can see the distribution here also going from a calendar year, January to December, that some of the wild variants are flowering more times out of the year. And this effect we see with our seedlings being exported, clustering so much, we attribute to the selection of the most aesthetic varieties, thus excluding a lot of the other potential flowering times. You can see some of the ecotypes I'm referring to down here. So we have massive genetic variation in the appearance of our cynas. Then what we learned from research on other, what we call medium-sized Protea. In referring to medium-sized Protea, that's not a king, not a queen. So if you look at this bouquet, it's everything else in this bouquet. What we've learned from research on medium-sized Protea was the who, cultivar-specific responses relating to the parentage on flowering time, the what, inductive conditions, that leads up to flowering, under what conditions are flowers induced. The where, we've found that that's on shoots meeting a certain threshold stem criteria, so a certain amount of flushes and a certain diameter for a shoot to be able to initiate a flower. and the when. So research using bud dissections could pinpoint the exact time of flower formation in many of these medium-sized Protea that gave us a very accurate idea of when we can come in with certain manipulations regarding flowering time. And all of this research enabled the researchers to then conclude on the underlying effect on flowering time to be related to carbohydrate dynamics, which in itself is multifactorial, and we could start to address each of these individual factors themselves. So in applying this to research on king Proteas, such as Arctic ice, the first step into delving into this, these factors influencing flowering time, would be firstly, where do these flower buds come from? And secondly, are there any factors modulating the flowering time after bud initiation? The Protea pink ice is a perfect example regarding this. Flowers developing through summer have a shortened developmental time, around 4 months, when compared to flowers that develop through winter. So flowering there is modulated by the season, which in turn influences the date that you actually pick that flower. Then completing the commercial picture, I'll be addressing some factors regarding physiological defects we've experienced in Arctic ice and how this relates to post-harvest management as well. This study therefore aims to characterize the flowering behavior in Arctic ice, to determine the origin of inflorescence buds, and then assess how seasonal bud development impacts on post-harvest performance. To do this, so as part of our commercial production strategy, future fynbos licensees report the export figures of Arctic ice in increments, and I'll be showing you some of that commercial data. Then we undertook bud tracking of Arctic ice buds. This was done on a mature Arctic ice orchard situated in South Africa in the Western Cape, also on Piketberg Mountain, like Eugenie's site. Buds were tagged once confirmed to be a flower. So on visual confirmation, it says they went 5 centimeters in length. That's about 2 inches for you Americans. The flower buds were tagged, and then monthly measurements were done on the same bud to see what the rate of maturation would be. So we measured the length of the bud and the bud diameter and followed that up until the harvest of the flower. Then the equation used for growing degree days as it relates to bud maturing was used for temperate zone crops of 10 degrees. Then I'll be reporting on a vase life section. So Future Fynbos undertakes regular vase life trials each and every season of Arctic ice harvest to establish baseline flower quality. So what can we expect from flowers harvested during different times of the year? I'll be reporting on that, and then I did my stats in our studio. So if we look at the commercial production trend of Arctic ice, it differs a bit from what you saw on the first slide with our export data. So Arctic ice has 2 general flowering periods. In the Southern Hemisphere, we refer to the first as our autumn flowering period. So that's from April, May, June, and then tapering down in July. And then our spring flowering period occurs majority October to November. This is given for the years 2022 to 2023, just to give you an indication of how Arctic ice flowers. These peaks, crests, can be moved either side by a week or so, but this is generally what we see in commercial production. And this begs the question, where do these buds originate from? So we have the 2 peaks, and then lower frequency flowering throughout winter and then also the summer periods. So we would very much like to know where these flowers came from. To do that, I mentioned the bud tracking. So I plotted the bud tracking data, and on the left is for length and on the right for bud diameter increase. So for each month of visual bud appearance, you have a line where a group of buds were visually confirmed as flowers. So then this results in graphs with varying slopes. So a steeper slope indicates more rapid development than a lower slope value. Slope values are given here down at the bottom, but since it's a bit small, I will interpret for you. So following the bud tracking, 3 distinct groups based on flower bud length could be identified in terms of the rate of bud maturation. The first group belongs to the buds that had the fastest length increase. Those belong to the July buds. So that would mean buds that develop in winter under our conditions. The second intermediate group, one of the largest groups in red there, primarily consisted of summer inflorescences, so that was January, December, and November. And then the third and last group was the slower maturing inflorescences. And these consisted of late summer to autumn inflorescences. So these flowers mature through the winter, and they had the slowest rate of bud increase. Just a comment on the diameter. Although significant differences were found in 4 slope values of inflorescence bud diameter increase, the discriminatory capacity wasn't as clear as for bud length. So we had a very large group not significantly differing from each other. So we found bud length a much better measure of flower maturation rate. Then I plotted the harvest data. Again, it's quite small, so I will be your eyes in this case. You can see it sort of mirrors what we see in the commercial production. I quite like visualizing data, the flowering windows, as these bars, that you can actually see how long your flowering window extends, when it happens in relation to the other groupings. So on the left, that's just the week's statistics. So the flower window, the start and the end of the flower window. In general, it was found that the average flowering window is approximately 6 weeks long. So from one bud group, you will harvest the flowers an average of over 6 weeks. There's one anomaly, and you might have noticed this long bar. This belongs to the March inflorescence buds. So March inflorescence buds had a 17-week flowering duration in between these 2 peaks. And this is, we found to be related to the fact that March inflorescence buds, a subgroup of them, have 2 months to mature in time for the autumn peak harvest. The rest of them will enter winter and assume slower development and be harvested as part of the spring peak, the second group, and then you have a trickle of a couple of flowers harvested in winter. So we can distinguish, as we did for the commercial harvest peaks, our 2 general flowering periods from these as well. So we see that the autumn flowering peak is made up of November and December buds here down at the bottom from the previous year, as well as all of the summer buds contributing to the autumn peak. Then the spring peak primarily consists of inflorescences initiated before the winter. So they will undergo winter to be harvested in spring. Then Arctic ice has a very interesting growth habit also as a cynaroides. It's extremely vigorous, and you have a lot of things happening at the same time on one single plant. So a single plant will have mature inflorescences, it will actively be initiating flowers, it will be undergoing root and shoot flushing, and unfortunately, it's difficult to see the bud group descriptions, but we basically have no new buds being initiated during the spring flush period in this orchard specifically. So the competition from spring flushing is just so immense that flower initiation is abandoned during this period to prioritize vegetative growth. Then, just a comment on the mean days to harvest. The longest mean days to harvest belong to a group of the autumn buds that go through winter, which is expected. They have slower development and are harvested in spring. But the November and December buds, which we call summer buds, also had a non-significantly different length of developmental time. And the only difference between those two groupings of buds are the growing degree requirement. So maturing through summer, these buds experience extreme stress conditions and therefore have a higher growing degree requirement to be able to mature a flower at the end of the day. Then on the post-harvest side, so how does this relate to the post-harvest aspect? We saw major differences in post-harvest life between flowers developing through summer and flowers developing through winter. We look at 4 main factors when considering vase life, or 4 main effects that can detract from a product quality point of view. So the first factor we look at is flower opening. We want the involucral bracts to reflex, to open up the inside of the flower. So for both summer developing flowers and winter, we still get successful flower opening. There's no major difference unless something goes majorly wrong, such as the flowers aren't harvested at the correct maturity. Then you won't get sufficient flower opening. The next very important factor we look at is the incidence of bract browning. So someone mentioned the fingernail syndrome. This is more or less the same thing. Here's a very extreme example. I wonder if the contrast isn't great, but you see the brown lesions developing on the involucral bracts. So this is especially significant in a white product. We don't really see it that much or are bothered by it that much in a pink or a red product, but because it's white, you see it immediately. This is a severe example. We don't really tend to see examples like this. So for summer flowers, we can expect after 7 days in a vase, just in water, no support with flower food or anything, you can expect to have around 30 to 80% of bracts affected to varying degrees by bract browning. Whereas your winter flowers have a mild to moderate incidence of bract browning. So we often see around 30% of the bracts affected by bract browning. Again, that's after 7 days in a vase, so they've been sitting there a while. Then, in terms of leaf blackening, for cynaroides, leaf blackening is a lesser issue than what you might have experienced with a lot of the medium-sized Proteas. So the onset of leaf blackening in summer flowers we find is also a lot earlier, since they don't really have the legs to carry them through for long enough. Again, just to mention, bract browning and leaf blackening will happen. The point of onset is what we are interested in. When will the defect start to occur? And then, as I said, for leaf blackening, it can be severe in summer flowers in some instances, both in the number of leaves affected and then the progression of leaf blackening. So at onset, we can have a light blotching all the way through just a petiole affected, whereas in severe cases, it'll cover the whole leaf. If we look at leaf blackening, what we expect to find from winter flowers, it's much less severe in the leaves affected and also the severity of the symptom. So just 1 or 2 leaves affected, that's the 30% mark. Then in terms of defects, in summer flowers we observe a couple of defects that in winter flowers are very rare to be seen. The first one over there is an example of blown flowers. So what we describe as blown flowers would be a flower where the florets open before the involucral bracts have a chance to open. That can happen on the plant already, and the flower is immediately downgraded. Also, small flowers are common among the summer flowers, but both blown flowers and small flowers are directly attributed to irrigation management. So in winter, this hardly ever occurs. Then, in conclusion, we found flower bud length, not diameter, is the best measure of tracking flower bud size increase. Arctic ice buds initiated throughout the year mature at different rates due to different requirements in terms of growing degree days. Then, flowers that develop through the summer are more prone to early onset of physiological defects. So the seasonal origin of your flower becomes so much more important in terms of plant and post-harvest management. I'd like to thank you all, and you can find our Ayoba flowers on Instagram as well. Thank you.
Thank you, Naomi. We'll take questions now for Naomi. Right here? Okay.
2 questions for you. On the grower degree days, do you start that when you first see bud initiation? Is that when that clock starts?
So especially for cynaroides, it's quite difficult to confirm them as flowers. That's why we use the 5 centimeter, 2 inch measure. So we know that flower isn't going to do anything like abandon bud development. We have incidents we call floral reversion, where the bud abandons flowering and the vegetative shoot resumes growth. Then you lose the flower. So I wanted to use a measure that a grower can walk into an orchard and see that this is confirmed as a little white bud. Let's track it from this size. Anything smaller than that is very difficult to follow. So in terms of flower initiation, it happens slightly before we see that visual bud.
Okay, so is that 2 inch is where you start your mark?
Yes.
And then after you've done that for multiple seasons, is that very predictable after that? That you can see that those grower degree numbers, that's going to be a very good indicator of when that flower is ready for harvest?
I would allow for about 10% variation just due to the seasonal temperature changes. But if you have someone, a dedicated technical person you can send into an orchard to do some bud tracking for you, it's a lovely way of being able to get a better handle on your harvest predictions. It's very difficult with something like Arctic ice that actually flowers year-round to be able to predict when we can harvest a flower. So that was the whole reasoning behind this study. Yeah.
Very good, thank you.
Other questions? Right here.
I bought an Arctic ice from Hershey. It's grown in the shade. I guess
they grew it in the shade because I don't know if they want good growth, but how does the light affect them? And you move it from the shade to the sun, and also why isn't Arctic ice produced more in this area versus the other ones?
So your question on light. Light is crucial for carbohydrate assimilation. And there are some lovely studies confirming that in medium proteas as well. We need light to build up carbohydrates to be able to produce a flower at the end of the day. Arctic ice, due to its extreme vigor, can assume a pattern of continuous vegetative growth under very low light circumstances, which means you're not farming with an economic plant. So if you don't produce a certain number of flowers per plant a year, then there is an issue. And more often than not, it's due to either, again, as I said, carbohydrate dynamics are multifactorial. Light is just one part of the equation. Your feed is another part, the soil you stand in, your wet season. Everything adds up to the capacity of a cynaroides to be able to produce a flower. And then the widely planted question.
So why isn't it more available, the plants, or why isn't it grown more here in California versus the other, the cynaroides? Why is this not grown as much here?
So I, as I said in the beginning, also work for Future Fynbos, and we license growers to produce Arctic ice. So it is protected. So it's not widely propagated due to that.
Can we regulate flowering, bud initiation or bud development with physical or chemical methods?
Sorry, can you repeat the question?
Can we regulate bud initiation and bud development with physical or chemical methods?
So if I had the answer to that, I would have been retired a long time ago. So a large part of my master's study was exactly on that. Can we initiate a flower to especially, I'll go back to this, to produce flowers more continuously, not have the peaks, because we want, a key to industry longevity is market continuity. So there are lovely trials, and Keanu Martin from Stellenbosch University will be presenting on that as well. We've also done trials with plant growth regulators, but I don't have a conclusive answer on that for you, sorry.
That's very important for the tool because sometimes the price is very high.
Yes.
And if you are using some physical methods like pruning or cutting branches or using growth regulators, you can initiate flowering as well as make it early or late.
It's not
very important research to be done.
Definitely, and it's not as easy as with the medium proteas. I mean, we use that as our starting block. And like Eugenie also said in her talk, cynaroides is a completely different animal.